Hello and welcome to our webinar on equations of circles. I know this is kind of weird. It looks like it's the last section of the book or the last section of this unit, which it is, but we're going to kind of start with it because I think that it is a good unit and it's a good algebra unit for us. This lesson needs to be viewed before 4/5. That is the Tuesday you get back from spring break, so you need to watch it before class so that you know what's going on when we get to class. So we're asking you to find the total distance between the 2 points. This is our in for the day. If you want to pause it and try it on your own, then that would be great. If not, I'll just go through it. So we're going to say that x1 and y1 are the 0, 0 that they gave me up here as my points, my beginning points, and the 4, 4 will be my values for my x2, y2. And so they're kind of giving you the way to find the distance formula with this triangle. And so if I'm going to solve this, I need to either follow the distance formula or Pythagorean theorem. I'll do it with the distance formula first, because that's where the y2 minus y1 and x2 minus x1 come into play, but we'll talk about it with Pythagorean theorem too quickly. So if I want to find the distance following the distance formula, I have this big long square root, and basically I set it up just like this, and now this parentheses are the two x's subtracted from each other, x2 minus x1. Well, x2 is 4, x1 is 0, so 4 minus 0. And my y2 minus y1 would be 4, take away 0 also. And so then if I do a little simplification underneath that square root, I end up with 4 squared, which is 16, plus 4 squared, which is 16. So I'm going to end up with d equaling the square root of 32. And in simplest radical form, because that's the way they want us to leave it, 32, as you can see up here, is 16 times 2. So I'm going to write that. And so it's going to be the square root of 16 times 2. And you'll notice 16 is a perfect square. So if I take the square root of 16, I get 4. So the distance is 4 root 2. So that is the actual distance in simplest radical form. I could have done this with Pythagorean theorem. I would just have to know what the length of the x side is and the y side, and you'll basically be doing the same thing. So if you notice, if I'm going from 0 in x over to 4 in x, that side is 4. This side, changing in y, is 0 to 4. So that's also 4. So if I say side squared plus side squared equals hypotenuse squared, then I end up with 16 squared plus 16 squared, or 16 plus 16, equals d squared. And if I take the square root of d, you'll notice that I end up with, well, what's 16 plus 16 is 32, equals d squared. So then that's basically getting me back to this problem right over here, and it's just the simplification that I need to do. And so then so you can see that it's square root of 32 will end up getting the same thing. So you can either do it by distance formula, Pythagorean theorem, whichever you like. So now we're going to move into equations of circles. And this equation of the circle is something that you absolutely need to know. You need to know that the radius is basically the distance formula. The x is subtracted from each other, the y is subtracted from each other. And you also need to know this equation up top up here, which is the equation of a circle. And that's the one that we're going to use the most up here, and the one I put in green. So make sure you copy these down. You can see the radius would be basically finding the distance between h and x minus k and y. Basically, it's the same thing that we've been doing with the distance formula. It's just a matter of that we're setting it up as an equation of a circle. So let's see how this works. And pause it if you need to copy it down. So here's an equation of a circle, or here's a circle, and they're asking us to write the equation of the circle. Well, you'll notice that I am centered at 0, 0 right here. So that is one value, and I don't know how far out x and y it is. So I'm just going to go through, and since they told me write the equation of a circle, we need to remember, is x minus h squared plus y minus k squared equals the radius squared. Now, I haven't talked about this h and k very much or at all, and the h and the k values are basically with the center if it's anything other than 0, 0. So if my center was up here at this point, the h value would be -1 and the k value would be +2, and that's what would go into these for h and k. But since we're at 0, 0, I'm going to set it up that way, and that's kind of the point that what they skipped over here. So I would say x minus 0 squared plus y minus 0 squared will equal, now my radius is just from the center to one of the sides, and the best side to go is a straight line, and you can see that I've got 1, 2, 3, so my radius squared. And so then that's what they got, that's how they got this equation, x squared plus y squared equals the radius squared, and you can see from that they went down to x squared plus y squared equals 3 squared. And so a little simplification, we get x squared plus y squared equals 9. That's just squaring, and that's the answer. That's the equation of the circle. That's really all you have to do. So that's if it's centered at 0, 0. You're not going to have anything added to x or y. They're just going to go away because they're 0, 0. So moving on, now we want to find the standard equation with the center at 0, -9, and a radius of 4.2. So we have to remember our equation of a circle, and our equation of a circle is x minus h squared plus y minus k squared equals radius squared. So they gave me h value over here. The center is h value, so that's h, which is 0, and k, which is -9. So plugging them into that equation, I'm going to say x minus 0 squared plus y minus -9 squared will equal my radius squared, which is 4.2 squared. So we have our equation of our circle. We just need to simplify it now, and if we simplify it, then we will end up with the actual equation. And so x minus 0 squared is just x squared, and then in the parentheses you got to remember what it means to subtract a -9, and so we would say that, and actually I'm sorry I messed up here, that square should be outside the parenthesis. Sorry about that. And so if I am subtracting a -9, I end up with y plus 9 squared, and then that would equal whatever 4.2 squared is. So I'm going to get out my calculator to find out what 4.2 squared is. 4.2 squared is 17.64. So that is 17.64. So there is my standard equation for the area, or for the equation of the circle. So there it is. You can see, follow the steps, copy them down. They're the same steps as I have there. It's just a matter of going through and writing out the equation of the circle. So now they're asking us to write a standard equation for a circle with a given center of 0, 0 and a radius of 2.5. Now this is very much like the first example that I gave you, and so you need to go through and start with our equation, which is x minus h squared plus y minus k squared equals r squared. And so knowing that equation, I know that h and k are both 0, so x minus 0 squared plus y minus 0 squared will equal 2.5 squared. Well, x minus 0 is just x squared, y minus 0 is y squared, and 2.5 squared, well, let's get out our calculators in case we don't know what it is. 2.5 squared is 6.25. 6.25. And so that is the equation of my circle that they're looking for. And there you go. There's our match. All right. So hopefully you're getting the hang of this. And so we're going to move along. See, we'll try another one. Same idea. This time they move the center and the radius. Please pause it and give it a shot on your own before I do it. Well, for the sake of tape, I'm going to move on. So I start out with the equation x minus h squared plus y minus k squared equals r squared. That's my standard equation. That's what I want every time. Plugging in h to be -2, so it's going to be x minus negative 2 squared plus y minus 5 squared equals 7 squared. So I just plugged in the given information, and now I'm just going to simplify it. Now you'll notice that as I do this, when I do my simplification, I get x plus 2 squared and y minus 5 squared equals 49. You'll notice if you look at these guys right here, the positive 2 and the negative 5, they look similar to the center over here, but they're always the opposite of what you see. So if I give you an equation and ask you to tell me what the center is, then you look at these points. This value with the x is the x value, but you got to switch the sign, as you can see over here. And the same thing with the y value. The negative 5, well, it's really positive 5. The 7, you just take the square root of that number and you'd find the radius. So that's my final equation, and so there's an equation that you would look for. That's the standard form equation that we're looking for. So hopefully you're getting the hang of this. So we're going to move along now. This time I gave you the point negative 5, 6 is on the circle. So this point out here, negative 5, 6, is on the circle with a center of negative 1, 3. Write the standard form of the equation. Well, you can pause it and give it a shot on your own. The one thing we don't know about this equation is what is the length of the radius. We know where the center is, so if I go back to my standard equation, x minus h squared plus y minus k squared equals r squared, and I could put in my center, so it's going to be x minus negative 1 squared plus y minus 3 squared. I just don't know what the radius is. And I'm not sure, it looks like straight across would be the radius, but I am not sure that's actually the radius. So I'm going to find the length of the line between these 2 points, because I know I can find that exact length of that line, and that will be what r is. So I'm actually going to do it. I'm going to do it like Pythagorean theorem, just to make my life a little easier. So I'm going to draw a little right triangle in here. But you can use the distance formula also. And if I use Pythagorean theorem, you'll notice that it's 1, 2, 3, 4 is the length of this side, and 1, 2, 3 is the length of that side. So, knowing my Pythagorean triples, I know the radius has to be 5. Now, is that the same as the count straight across? Yes, it is. It would just happen to be luck that way, but that's what we're talking about. So my radius is 5. So to finish off this equation, I'm going to replace the radius down here, the r, with 5. Simplify 1 minus negative 1, so x plus 1 squared plus y minus 3 will equal 5 squared, which is 25. And so that's the 5 squared, because I just found it. And you could do it by counting if it's straight across. Sometimes you can trust it, sometimes you can't. I would go with the distance formula or Pythagorean theorem. And the distance formula will get you the same thing. I just thought Pythagorean theorem might be a little easier there. So again, look at the points, look at the h. The h value looks like positive 1, but you'll see the center is really negative 1. Remember, they're opposites. Looks like negative 3, but it's really positive 3. So when we ask for the center, switch the signs on the values of x and y, and that will give you the center. Take the square root of this number, and that will give you the radius. So now we're asking you, oh, and this is just the last problem. This is the solution to the last problem, just kind of working through. They found the radius by using the distance formula, and then they went through and plugged it into the equation. And so you had your standard form of the equation. So you can pause it and copy it down. It's the same as what was on the previous page, but I just thought you probably would like to see that. So